Today we're going to look at how to solve radical equations. So radical equations, just like any equation, when you want to solve, you always want to get the variable by itself. The process is usually just doing PEMDAS backwards, with a couple exceptions. I'm going to skip those just for the sake of simplifying things. Okay, now remember, you can do this stuff graphically versus algebraically, and that's what I'm going to recommend all the time. The only thing, or the only solutions that won't work or you can't find, are imaginary solutions. So I'm going to actually put this up here at the top. So solving graphically will not show complex solutions. Right, just because a complex number is an imaginary number. So it's there even though you can't see it. Now, again, a solution is where the graphs intersect at what x value. Radical solutions, or excuse me, radical equations is going to be our first look into extraneous solutions. Now, I don't know if kids still say this now, but what I think of is extra. Okay. All right, a couple years ago, if somebody says you were being extra, you were doing too much, right? So extraneous solutions are too much. Strain, right? If somebody puts a strain on your life, right, they're kind of making it difficult. Okay, so extraneous solutions are just extra solutions that don't really do anything, or they don't serve a purpose except to put strain on us because they don't even work. Okay, so again, extraneous solution is where you do all the math correct in which you solve for the missing variable and the answer doesn't fit the original equation. In short, it's not a final answer, so you would exclude it. Okay, I'm gonna do in this video examples that do not have extraneous solutions, but just kind of cover the basics of solving the equations. So again, here, if I want to think of this and rewrite it, I could rewrite this as x minus 6 raised to the 1/2 equals 3. So PEMDAS, right? I said to do this, you just do PEMDAS backwards. So the first thing we see is parentheses. Okay. So I have parentheses, then my exponent, and that's it. Okay. So I want to now start with exponent. So when I solve, I'm going to eliminate the exponent. And I forgot here, I have subtraction at the end. So after I eliminate the exponent, I'm then gonna get rid of the parentheses. And then last but not least, I'm gonna do the opposite of subtraction, which means I'm gonna add. Okay. So the way I get rid of this exponent, right, is to square both sides. So x minus 6 to the 1/2 squared is equal to 3 squared. When I do this, it cancels. So I'm just going to be left with x minus 6 is equal to 9. So I just eliminated the exponent. Now I want to get rid of the parentheses. There's nothing here to like simplify or perform operations on the parentheses anymore, so I can just drop them off. After I get rid of the parentheses, I'm going to undo subtraction by adding 6 to both sides. In which I get x is equal to 15. Now, that being my final answer. And you always want to go back and double check your work. So where you see a variable or what you solve for, you're going to plug that number into your original equation, and it must fit your original equation, okay? Now I'm just going to simplify. 15 minus 6 is 9 is equal to 3. Square root of 9 is indeed 3, and 3 is equal to 3, so it works. So I'm going to finish it off with putting a check mark. Now, again, I can always go y equals, type what I see on the left. I get to the equal sign, I stop. I start a new y equals, type what I see on the right. And I want the x value where these intersect, and if you look, it's at 15. And that's how I personally solve all of these equations. Reason being is I can eliminate answer choices that have wrong solutions that are real numbers, so extraneous solutions, right? Ones that somebody got one way or the other, but it doesn't fit the original equation, so it still doesn't work. Okay, the only thing that's going to leave me with having to test is the complex solution, in which I just have to go through, plug it in, do a little bit of math, and get to my answer, because again, a complex solution is made up of imaginary numbers. So just take your time on those and you should be okay. Again, I'm going to solve this graphically again. Y equals square root x. So again, over here, I'm going y equals square root x, y equals 10. And again, I want x value of intersection is y equals 10. All right, then you just zoom out until you see where they cross. If you click your cursor back on the equation you typed in, Desmos even put the dot there for you. And again, it's 100. So not a ton of math involved here. If you want to be an overachiever, again, you can try to do it by hand. So what I see going on this side on the left, whoops. So I only have one variable here. So again, I want to try and get this variable by itself. So I want to solve for m. So if I talk about the stuff that's going on to the side that has my m in it, I have a radical, which is really exponents. After I take care of the radical, what's being performed is division, and that's it. So I'm going to go to undo it. I'm going to eliminate the radical. After I eliminate radical, I'm going to multiply. So again, 10 equals square root m over 10. The way I do get rid of radicals is I square both sides. After I square both sides, I get 100 is equal to m over 10. So I got done with my radical. Now I need to multiply both sides by the denominator. When I do, I get m is equal to 1,000. Again, just going to go back and double check my work. Y is equal to 10. And then y is equal to square root, division, m over 10. I left off y equals. Need to put it. And so from here I can do a couple things, right? I can zoom out, but you see I had to go to 1,000, so that's a lot of zooming, right? But Desmos shows it to me, and it's 1,000. Now another way you can do this, if you want to, is focus solely on your tables. So again, if I pull up a table of both equations, here I would just come in, I will plug in answer choices. So say if I thought it was 100, okay, I get 3.16. When I come down here and I put in 100, it needs to be 3.16. If it's not the right answer. All right, I got 1,000, so I'm going to type in 1,000, and my y value is 10. And again, remember, solutions to equations is the x value that gives you the same y value. So again, I'm going to test 1,000, and if I look, it gives me 10. So both of these are 10, therefore that was the correct answer. In the next video, we will go over solving radicals that have extraneous solutions.